You ever wonder why your favorite shopping site just dies during a big sale? Or, on the flip side, how your bank can spot a bogus charge in the split second it takes you to swipe your card? Well, the answer has to do with this massive, almost invisible shift that's happening under the hood of the internet. We're moving away from a digital world that's built on waiting to one that's built to react instantly.
So here's the game plan. First, we're going to unpack this idea of the fragile wait state. You'll see what I mean. Then, we'll dive into the radio broadcast revolution that's completely changing things. We'll look at the tech making it happen, Kafka, then a quick reality check, because nothing's perfect. And finally, we'll see how all this real-time magic is changing, well, everything.
Okay, so let's kick things off with the problem. It's something every single one of us has felt, but you probably didn't have a name for it. It's what we're calling the wait state. And it's a problem that's been baked right into the foundations of the web from the very beginning.
I mean, it really all boils down to this, right? Why, after decades of the internet, do huge multi-billion-dollar companies still have their sites just fall over on the busiest day of the year? It feels like it should be a solved problem, but the reason it's not is actually buried deep in their architecture.
You know, if we were going to give this problem a villain name, a real bad guy in our story, it's this: synchronous coupling. Yeah, it sounds super technical and boring, but the idea behind it is actually pretty simple. And as we're about to see, it is incredibly fragile. So here's the core of it. The old way of building things works just like a telephone call. Your browser calls a server to check inventory. That server then has to call another service to handle the payment. And here's the kicker. Every single system in that chain has to hang on the line and wait for a direct response before it can do anything else. The whole system is just constantly waiting. And this right here is the domino effect, because all those services are tied together so tightly, if one of them slows down or fails, it takes everybody else down with it. The entire system is only as fast as its absolute slowest link. So when that one little inventory service gets slammed on Black Friday, the whole house of cards just collapses. All right, so how do we fix this mess? Well, the answer isn't just a small upgrade. It's a total revolution in how computer systems talk to each other. We're moving away from that old, clunky telephone call model and embracing something new, the radio broadcast. Now, this is the part that's really cool. Instead of a direct telephone call, picture a radio station. One service just broadcasts a message out into the world, like, hey, an order was just placed. It has no idea who's listening. And honestly, it doesn't care. Other services, like shipping or inventory or analytics, they're the listeners. They just tune in to the right frequency and react whenever they hear something that matters to them. No more waiting. So, this chart really breaks down the trade-offs for the architects building these systems. The old telephone way is tightly coupled, but it's simple and fast for direct requests. This new radio way is loosely coupled and can scale to insane levels, but yeah, it's more complex to set up. The takeaway here is that we're moving toward a hybrid world. You still get that immediate telephone-like response when you click a button, but all the heavy lifting is happening in the background using that powerful radio model. Now, this whole radio broadcast idea sounds amazing in theory, right? But to actually make it work at the scale of a global company, you need some serious heavy-duty technology. And that, my friends, is where Apache Kafka comes in. It's pretty much the digital backbone for this entire revolution. Okay, so a really common mistake is thinking Kafka is just another messaging system. It's so much more than that. The proper term is a distributed commit log. What that means in plain English is that Kafka doesn't just pass a message along and then forget about it. No, it writes every single message down in a permanent, ordered list. It's creating a perfect, unchangeable record of everything that has ever happened. Let's just break this down real quick. First, you have a topic. Just think of it like a category or a playlist, like new customer signups. Now, to handle a crazy amount of data, that topic gets split into multiple partitions. This is Kafka's secret weapon for scalability. Different systems can all read from different partitions at the same time. And finally, every single message inside a partition gets a unique serial number called an offset. That way, the system never loses its place. Now, for things like your bank account, you obviously can't afford to lose a single transaction. It's just not an option. Kafka guarantees zero data loss with this really clever replication process. See, a message isn't actually considered sent until it's been safely copied to multiple different servers. Only after those copies confirm they have it, does the system finally say, okay, got it, we're good. And if you're still wondering why Kafka is the tool of choice for this stuff, well, just look at this chart. Look at that difference in throughput. It's not just a little bit better, it's an order of magnitude faster. Kafka is engineered to handle over 15 times the data volume of a traditional system. I mean, that's the kind of raw power you need for this real-time world.
But okay, let's hit the pause button and have a quick reality check. With all of this incredible power comes, you guessed it, a whole lot of complexity. This stuff is not a magic wand you can just wave. Getting it right introduces a completely new set of challenges that can be really, really tough to manage.
Suddenly, you have to worry about bizarre things like rebalancing storms, where the whole system just grinds to a halt, shuffling data around. And there are very real costs, especially in the cloud. You literally pay for every single byte you copy around. But maybe the biggest headache is data governance. If you're not careful, one badly formatted message, what engineers call a poison pill, can get into the system and crash everything downstream that tries to read it.
So how do you stop those poison pills? Well, the answer is a tool called a schema registry. The best way to think about it is like a bouncer at a nightclub for your data. It stands at the front door and enforces a super strict contract for what the data has to look like. If a message shows up that doesn't follow the rules, it gets rejected right there, protecting all the other systems inside.
Okay, so after dealing with all that complexity, you might be asking yourself, is this really worth all the trouble? And the answer is a resounding yes, because what this architecture enables isn't just an improvement, it's a total game changer. Let's look at how it's actually saving the day out in the real world. This quote really just nails it. In today's world, for any serious digital business, being able to react in milliseconds isn't just a nice-to-have feature for a competitive edge. Nope, it's about basic survival.
And here's the perfect example: fraud detection. The instant you swipe your card, that action becomes an event that hits a Kafka stream. Within milliseconds, it's combined with your purchase history and location. An AI engine analyzes it for weird patterns, like something called impossible travel. Did you just buy a coffee in New York and then try to buy gas in Tokyo 5 minutes later? If something's fishy, an alert is triggered to block the charge before the fraudster even gets the receipt. It's incredible. And the scale here is it's mind-boggling. A single big telecom company can generate billions of these little events every single day. And this kind of architecture handles all of it, in real time, powering things we totally take for granted now, like getting an instant text message with your new data balance. That's all this real-time engine working behind the scenes.
So this all leads us to one big final question. The old wait state is dying. It's being replaced by systems that can sense what's happening and respond immediately. As this technology becomes the new normal, it really makes you think, are the tools you're building and the services you use every day still built to wait, or are they being rebuilt to react?